In this video, we're going to be talking about sections 5 and 6 of chapter 1. I combine those two sections because they're talking about adding and then subtracting real numbers. To me, those two things should be going hand in hand. There's nothing in here that is just a mind-blowing thing. However, if you haven't been doing this, if you've been using a calculator for years, please practice. Give it the time that it needs, and it will come back to you. But we want to be able to do this on our own. Out of everything that we're going to be talking about in this class, we're going to talk about some very important, useful things. But this is the most important thing there is, just being able to do basic arithmetic on our own. That doesn't mean you have to be fast or do it in your head, in half a second, but we just have to be able to do it. And that means writing it down. If you can do it in your head, great. But if not, write it down. Don't be afraid to do that. So let's jump into this. There's not much that I want to talk about with these two sections. I just want to show you the ropes on this, and then it'll be up to you to practice. So this is section 1.5, 1.6. We are adding and subtracting real numbers. Okay. Now, how you think through these problems is completely up to you. There are a lot of ways to do this. There is a rhyme that I heard many years ago. I'm going to show that to you here to kind of help you remember the rules. Also, you can just think of it like money. If you have positive, that's income coming in. If you have a negative, that's a debt. That's something that you owe someone. So if you think of it that way, a lot of these rules just come out naturally, and you don't have to try and memorize something. But if you do like just flat out rules to follow, here's something that you guys can utilize. So it goes something like this: same sign, add and keep, different sign, subtract, keep the sign of the bigger number, and this last part just helps it rhyme at the end. Keep sign of the bigger number, then you'll be exact. Again, that last line is just to kind of help it rhyme at the very end to tie it together. So there are two different things here. You've got same sign, add and keep, and then different sign, subtract. This is telling you what to do with different signs. Okay, so same sign, you add them, you keep the sign. Okay, if they're both negative, you keep the answer negative. If they're both positive, keep it positive. If they're different signs, you subtract. How do we say subtract? A lot of times we'll call it a difference. So if they're different signs, find the difference. We subtract them, but then we keep the sign of the number that's bigger. And we're talking about just the number itself, not the, all positives are bigger than all negatives, but we're talking about the number itself. So let's just do some quick examples. Let's say we have 324 plus 89. Okay. Again, if you can do that in your head, great. If not, that's okay. First thing I want you to do is determine the sign of the answer. You're adding, and there's two positive numbers. Now, you could think of this as a positive 324 plus a positive 89. Or you can think of it as a 324 combining with a positive 89. When we get into algebraic expressions and equations, yes, this is an addition, but you could also just think of it as listing two things next to each other. This sign attaches itself to the following number. Okay, so we've got this addition here, same sign. I'm going to add them, and I'm going to keep that positive. So to add that, let's just go through that really quick. Again, if you can do it in your head, great. But if not, don't be afraid to go through this process. 4 plus 9 is 13, carry the 1. 8 plus 2 is 10, plus 1 is 11, carry the 1. And then 3 plus 1 is 4. Okay, and we already determined that's going to be a positive value, so a positive 413. That's it. Okay, how about something like this? Let's say that. Okay, now it's a negative 51 minus 42. Okay, you could also think of this as adding a negative 42. That's another way to think of it. That's why I don't really like how they separated addition and subtraction. Subtraction is just adding the opposite. They're one and the same thing. Now, the problem with writing it like this is that you're throwing in a lot of signage that we then have to filter through later on when we get into equations. I really would avoid doing this. There are a couple times where it's helpful, but with arithmetic, I wouldn't do that at all. I would just leave it as a negative 51 minus 42. Okay. Now, again, you are combining a negative 51 and a negative 42. They have the same sign, so I'm going to add them, but I know for a fact that my answer is going to be negative. Okay, without doing any calculation, I know it's going to be negative because I keep the negative sign they have in common. And then I just add. Notice I'm not writing that negative sign anymore because I already took it into account. And I add those up. And there we go. Simple as that. Let's look at a couple more. How about something like that? Okay. Now, these parentheses here, a lot of times we would use parentheses to show multiplication. But in this case, since that addition sign is there, we are just adding. The parentheses are simply there to visually cue you and remind you like, hey, there's a negative sign there. Don't lose it. So really those parentheses are just a visual cue. This problem here, we have a positive. We're combining with a negative. So we are going to have different signs. Therefore, we subtract. However, think of the sign of the answer before you do the calculation. We have different signs we subtract. Keep the sign of the bigger number. 13 or 62? 62 is bigger. So I'm going to keep the negative that was attached to the 62. Go back to that money idea that I brought up earlier. Let's say you have $13, but you owe somebody 62. If you give them the 13, you're still going to be in debt. Therefore, the answer should still be negative. Find a way to think it through and stick with it. Okay, whatever works for you, figure it out, stick with it, and it'll be a lot easier. Now, when we subtract these, watch what I'm going to do. Do you see how I took that negative and now it's on the 13? That's okay. I can make that switch because I already took that negative into account. So now I'm just trying to find the difference. So when I do that, remember how to borrow. I'm going to take 10 out of this to make it now a 5 or a 50, but then I attach that 10 onto the 2 to make it a 12. So 12 minus 3 is 9. 5 minus 1 is 4. I already determined that answer should be negative. And there we go. Okay, be patient, take your time with it, and again, try to do this on your own. If you have to do it like this, go for it. And even if you can do things in your head, know your limitations, okay? Know where that cutoff is, where it's like, okay, no, I got to write this thing down. Don't force it, okay? Make it just come naturally. If it's something quick that just pops out of your head, great. But if you have to be hesitant, just write it down. The more you write it down, the better you're going to get at it, and the more you're going to be able to do in your head. One thing I want to talk about that we haven't really touched on yet are decimals. So I want to do a decimal problem here. Let's say we have that. Okay. Now, again, this is a positive 0.423 minus, or it's a negative that you're combining, a 5.2. Okay. So positive and negative, different signs, subtract. We are subtracting this. Okay, so when we subtract, you keep the sign of the bigger number. This is bigger than that. So I'm going to keep that negative sign as the answer, or on the answer. Now, when I actually subtract these things, I want to make it, just so the calculation comes out easier, the bigger number minus the smaller number. I know that's not how it's written here, but again, we can make that switch if we take that negative out at the beginning. So I'm going to put the 5.2, and when I subtract the 0.423, I line up the decimals. So watch how I'm going to write this. I'm going to subtract like so. The decimals are lined up. That is very important. So you're actually calculating the correct units together. Okay, when there's missing pieces here, I can just throw a 0 in. And now we're good to go. Okay, now notice we can't subtract here. Okay, we got to do some borrowing. But next door, there's nothing to get. So what we have to do is go further over until we hit something that's not 0. This 2 is going to bring this up to a 10. And now since that's a 10, I can borrow and make that a 10. Okay, so here I need to borrow. Go next door. There's nothing there. I'm going to keep going next door until there's something to borrow. And then once I do that, I can kind of have a domino effect going back to the right. And now I start subtracting. 10 minus 3 is 7. 9 minus 2 is 7. And then this right here, I have to do some borrowing again. 11 minus 4 is 7. And then 4 minus 0 is 4. Now, that decimal simply drops down. Okay, and don't forget, the very first thing we did was determine that that answer should be negative. So negative 4.777. And there we go. Again, there's not much to be seen or talked about in this section. It's a lot of repetition. And this is something that I wouldn't just work on for a day or two and then call it quits. If you are not where you would like to be, then you should come back to this section and practice throughout this course, throughout the fall semester and the spring semester and so on. Just keep practicing this. And as you're going further in this class with the algebraic stuff we're doing in later chapters, by not using a calculator, you're going to be practicing this. Okay, so just keep at this and it'll get a lot better. And this is such a useful tool for later on. One other thing that they do talk about in this section that I want to make sure we all have, they throw in the idea of complementary and supplementary angles. Now, there's a lot we can talk about with complementary and supplementary, but I just want to kind of get the general idea, the basic idea down so that when it does come up later in more complex situations, we have a foundation. So let's first list these out. So complementary and supplementary angles. First of all, what does it mean for two angles to be complementary? Complementary angles are two angles that add up to 90 degrees. Okay? If this was a geometry class, then we would be very careful with detail of wording and detail of application and the markings on the pictures, because when you see something that looks like 90 degrees, what does that look like? For instance, 90-degree angle typically looks like that. Okay, if this was a geometry class, there is no way we can assume that that's 90 degrees, because it could be 89.9 or it could be 90.3 or something like that. However, in this class, if you see something like this, it's 90 degrees, okay? Supplementary angles. Those are two angles that add up to 180 degrees. What would that look like? That would look like something like this, something like that. And we have the 180-degree, what we would call a linear pair. Okay, and back here, this is a 90-degree angle, but if we had two angles that added up to 90, it would look something like that. Okay, now what they're going to ask you is just very simply find the missing angle. So if let's say we have a picture like that, find x. Okay, looking at it, we know that this is a 90-degree angle altogether. We want to find what missing piece is here. Okay, now that x represents what we would call the leftover. That is a very important idea that is going to come up again and again and again. When we look for a leftover, okay, and we know a total of all the pieces, what we can always do is take the total minus what we know to get the leftover. Okay, so there's going to be a lot of times throughout this course where I mentioned the leftover problem. That's what we're talking about here. Okay, so 90 minus 41. If you want to do this in your head, take 90 minus 40. 90 minus 40 is 50. Take away one more for that 41, and we have 49 degrees. Okay, if you want to do this by hand, then do your borrowing. 10 minus 1 is 9. 8 minus 4 is 4. And there's your 49. Okay. Next one. Let's say it's a supplementary pair of angles. And I give you something like that. Okay. Same idea. It's just the total is different. The total now is 180. So I have 180 minus the piece we know. And then we can do that subtraction. If we do that by hand, again, do some borrowing. 10 minus 8 is 2. 7 minus 5 is 2. And then there's that 1. So we have 122 degrees for that missing angle there. If we wanted to do that in our head, think of it this way. If we have 180, subtract 50. 180 minus 50 is 130. And then 130 minus that extra 8 is 122. Okay? You could also go this way. 58 is close to 60, right? So 180 minus 60 is 120, but then there were 2 that I over subtracted, so that would bring us back up to the 122. Okay, a lot of mental math is estimating, okay, and then making the adjustments back to the exact answer. So that pretty much covers section 1.5 and 1.6 with addition and subtraction. Just practice, guys. That's really what it comes down to, is just practice, practice, practice. And if you kind of push the calculator aside, you're going to be practicing every single day that you're working in this class. And that's what you want to do, because these are the types of things that we want to get better at. Okay, so I don't care, even if you forget all the algebra, this everyone and anyone can use in their daily life. Okay, so work hard, stay safe. I'll see you next time.